and welcome to the Division of Education, Innovation and Energy e-learning program. I'm one of your maths facilitators, Joseph Frederick, and today we shall be continuing our exploration of factorization. Our objectives in this video are as follows. We want to factorize utilizing the grouping method. We have looked at that before in our last video. We then want to look at the factorization of differences of two squares. After that, we are going to look at factorizing a quadratic expression, and at the end of it all, the hope is that you will be able to appreciate the use of factorization in real life. Now, as we navigated algebra, we started off with an introduction where we looked at defining certain things and basic addition and subtraction, multiplication, division of algebraic terms and expressions, and then we went on to the distributive law. And now here we had factorization. We have two more topics to complete before we get to the end of our basic algebra exploration. Now, under factorization, what we had done thus far is that we looked at determining the highest common factor. Then we did a first approach to factorization, and then we did factorizing by pairing or grouping. And we want to look at today we want to look at using differences of two squares to factorize, and also factorizing a quadratic. And we want to end off our exploration today by looking at some mixed problems involving all of these methods of factorization. So today promises to be a very exciting day. This video promises to be very exciting. So let's go. So factorization, let's just recap where we were. Again, I want you to remember this, that success in mathematics, success in maths begins with a willingness to try. You must be willing to try. Make an attempt. The story is told of the guy that created the light bulb. They said he attempted to build this light bulb about 100 times before he got it right. Imagine you trying a maths problem 100 times. What is going to happen? After the first try, most people want to give up. We are saying that your success in maths, my success in mathematics, has been as a result of me wanting to try and two, never giving up. So never give up. So last video, we looked at factorizing by grouping. And I left you with some questions that I hope that you tried. So these were the questions. The question was, can you factorize utilizing the grouping method 4x squared minus 6x minus 2xy plus 3y? Factorizing utilizing the grouping method. You recall that what that was? We said that initially, when given any problem to factorize, the first thing that we do is to look across the entire problem to determine if there is any common factors, if there are any common factors. Once we have established that common factors exist, we factor them out. However, if we have an expression where it appears that there's an even number of terms and we can group them, and common factors exist in these groupings, then that's what we do next. So here, we look across this expression. Common factors? No. But can we group them? The answer is yes. So how do we group them? So this is the expression again. How do we group? You recognize here that we can group in this 2 by itself and this 2 by itself. So we have a pair and a pair. And for this pair, what is the common factor in this pair? The common factor in this pair is going to be what? The common factor is 2x, correct is right. And we ask ourselves now, 2x multiplied by what is going to give us the 4x squared? And then 2x multiplied by what is going to give us 2x multiplied by what is going to give us minus 6x. So 2x multiplied by 2x is 4x squared. And if you cannot recall how to multiply your terms in algebra, just check the video that we did on algebraic multiplication. We did that video for your benefit. So we go along. In the next pair, what do we have as the common factor? In the next pair, the common factor in the next pair is minus y. Taking out minus y here is going to be minus y multiplied by multiplied by what is going to give us minus 2xy. It's positive 2x. And negative y multiplied by what is going to give us positive 3y. It is negative 3. Again, there's something right here that you must pay keen attention to. The objective here is to ensure that whatever we have in this bracket, we have the same thing in these brackets here as well. So when we are doing our multiplication, again, check that video. When we are doing our multiplication, we are doing it, or when we are factoring out in such a way that whatever we have in this bracket, we also have in this bracket. So check that video for some further guidance. So now, what we have here, we have a term here and a term here. Looking at these two terms, do we not have a common factor? Of course, both terms have 2x minus 3. 2x minus 3. So what we do is that we factor out that 2x minus 3. Factor out 2x minus 3. What do I have in front of this bracket? 2x. What do I have in front of this one? Y. So after we have factored out the 2x minus 3 here, we then take what is in front of each of the brackets. So it's going to be 2x minus y. And we have completely factorized this here. Look at another one. It's 5x plus 3 multiplied by 3x plus y minus 2 multiplied by 3x plus y. This seems to be, a little different from what we were trying. Is it? Now look here. I want you to look here for me. Look here. When we got down to this part of the problem, here, what we said was this, that this comprised of two terms. There were two terms here. Here was a term, and here was another term. In this term, we saw in the brackets 2x minus 3. In this term, in the brackets, there was 2x minus 3. So what we did, recognizing that they both had something in common, what we did was to factor out whatever they had in common. Now, if we look across here, do we not see, or does it not appear as if these two, this could be viewed as a term, this is viewed as a term, these two terms have something in common. What do they have in common? In common here, what they have is 3x plus y. And in front of this 3x plus y is 5x plus 3. In front of this 3x plus y is negative 2. So what we will do is that we are going to factor out that 3x plus y. It is common to both of them. So we factor out that 3x plus y, and what do we get? So it's 3x plus y, it's common, so we factor it out. What is left in front of this 3x plus y is 5x plus 3, and what is left in this 3x plus y is negative 2. So we put them together as we would have done here. So we take out what is in front of both brackets. So what we did was to take one of these things that are common, and then we take out what is in front of both brackets. So we have 2x plus 3 and 2x minus y. That's what we did here. It is 3x plus y, that is common, so we took that out. And what is in front of this bracket? 5x plus 3. What is in front of this one? Negative 2. Now this here can be further simplified. I have positive 3, negative 2. Positive 3, negative 2 will give me, correct is right, will give me 1. So what we end up with here will be 3x plus y multiplied by 5x plus 1. And this here has been completely factorized. Now, so what that method that we looked at here, this method is a method that utilizes factorizing by grouping. There are 4 basic methods that I know to factorize expressions. Now recall that the first thing that you are supposed to do is to look across the entire problem and determine if a common factor exists and take out that factor. So once you are asked to factorize an expression, the first thing that you do is to look across that expression and determine if a common factor exists and you factor it out. If not, then you explore what other methods of factorization can be used to factorize that expression. So we looked at factorizing by grouping. The next method of factorization that we want to look at is utilizing differences of two squares. Now, let's explore this word here, differences of two squares. In order for us to apply this method, differences of two squares, one is that here's what. For us to use this method, here's what. A difference must exist. Now, in mathematics, when we say difference, what we mean is that some subtraction is taking place. Difference, 5 minus 1. Difference, the difference between 4 and 3. the difference between 5 and 1. With a difference, subtraction must be occurring. So when we say differences of two squares, there must be a subtraction of two what? Of two squares. So here, for us to apply this method, subtraction must be occurring between two terms. But the two terms must be perfect squares. I must be able to find some number or some term for which, when squared, would give me each of those terms that are subtracting there. So look at my question here. X squared minus 9. For x squared minus 9, well, both of them must be perfect squares. Yes. X squared minus 9, that's what we're working with here. So it's x squared minus 9. And the question is this an example of differences of two squares? Can I apply differences of two squares to factorize this? Is it a difference that is occurring here? That's right. It is x squared, and from the x squared we are subtracting 9. Now let's see. Now, x squared, is there any number or term that I could square to give me x squared? Is there anything that I can square? Of course. What can I square to give me x squared? To give me x squared, I can square x. X squared is x multiplied by x. That is x squared. What about 9? Is there any number or any algebraic term that you know that we can square to give us 9? Correct is right. What we can square to get 9 is 3. 3 squared is 9. So here, this here is a case of difference. This here is a case of difference of two squares. I am subtracting here. I'm finding the difference of x squared and 3 squared. Once we have established that differences of two squares is occurring in our problem, what we then do is to take the first term, x, add it to the second one, and then take the first one, x, subtract from the second one. And we have completed our factorization. Differences of two squares. So once we have established that it's a case of difference of two squares, this is what we do next. So our answer is x minus 3. Oh, wait, something is wrong here. Because here, I have x plus 3, x minus 3. But based on the answer that I'm seeing here, it is x minus 3, x plus 3. Something is wrong. Is there something wrong? No. When we started off algebra, we spoke to the commutative property. We said that multiplication and addition are commutative. So x minus 3, x plus 3 is the same as x plus 3, x minus 3. It's the same thing. Yes? Again, if you can't recall what is meant by the commutative property, please check one of our previous videos and you would see a full explanation on the commutative property. So once you recognize that differences of two squares exist, what you are to do. Let's look at another example. Factorize 4x squared minus 25y squared. Is this a case of differences of two squares? Do we have a difference occurring? Subtraction is occurring? Yes, subtraction is occurring. Subtraction is occurring, but are we subtracting two squares, two perfect squares? What can we square to give us 4x squared? 4x squared, what can we square? We can square 2x. 2x squared gives us 4x squared. What can we square to give us 25y squared? 25y squared, what can we square? We can square, correct is right. 5y squared is 25y squared. Again, just check back on that video that we did for multiplication of algebraic terms. 5y squared is going to be 5y multiplied by 5y, because the power here, or the exponent here, tells you the number of times that whatever the base is has to be multiplied by itself. So 5y squared is 5y multiplied by 5y. And 5y multiplied by 5y is going to give me 25y squared. So, is it a case of differences of two squares? Yes, it's a case of differences of two squares. Once we have established that it's a case of differences of two squares, we are then to take the first term, that is 2x, add it to the second one, 5y. Then take the first term again, that is 2x, and subtract from the second one, that is 5y. And we have completed our factorization. This is really nice. I love this. This is a nice method. Very short and sweet. Let's look at another example. M squared minus 1. M squared minus 1. Is that a case of difference of two squares? Let's check and see. Is it a difference? Of course it's a difference. Once I see the subtraction sign, I know that a difference is occurring there. So, is it a difference of two squares? My head is scratching me. I am trying to figure this out. Is it a case of differences of two squares? Let's see. What can I square to give me m squared? So I'm subtracting here m squared and 1. So we are saying it's a difference, but is it a difference of two squares? What can I square to give me m squared? Correct is right. It is going to be m, all squared is m squared. But what about 1? Can I square any number to give me 1? Of course, 1 multiplied by itself any amount of times is still 1. So it's going to be minus 1 squared. So now we have established it's a case of difference of two squares. How do we complete the factorization? To complete the factorization, we take the first term, m, add it to the second one, 1. Then take the first term, m, subtract from the second one, 1. And we have completed our factorization. This is really easy. Now, here's the thing about it. That almost every aspect of mathematics is easy. Once you have decided that you are going to, 1, know the rules, and 2, follow the rules. Once you know the rules and you're following the rules, most of mathematics, if not all of it, is very easy. But what ensures that you don't make the simple mistakes, when I'm marking papers, I look and I see that students may know exactly what they are to do, but they have made some simple mistakes along the way. How do you prevent yourself from making those simple mistakes along the way? My recommendation is to practice. Mathematics is all about practicing. Yes? So don't really think that you can sit there and just study maths. You must practice maths. So practice your maths. Let's go down the road here again. So we're looking at factorizing, utilizing the method of differences of two squares. So we have established that in order for us to use this method, 1, a difference must exist. When we say a difference must exist, we are saying here that subtraction must be occurring. Once subtraction is occurring between two terms, it is possibly a case of difference of two squares. But that's not the only condition. There's another condition. That the terms that are being subtracted, that we find in the differences of, those terms must be perfect squares. We must be able to find some other term or some other number that can be multiplied by itself to give us those terms. Once those two conditions are met, we then say that it's a case of difference of two squares. Once we have established it's a case of difference of two squares, we get down to this line. From this line, we say, take the first term, add it to the second one, take the first term, subtract from the second one, and we have completed factorizing, utilizing the method of difference of two squares. Let's look at 2 more examples before we move on. So look here. Whew. Okay. I think I have a problem here. Let's look at this for a while, take a break, and we shall be right back. You try it, no? You take it. Take it, try it. We shall be right back. Welcome back. I'm hoping that you were able to assist me some in factorizing this here. Upon looking at it, I had the feeling as if I would not have been able to factorize it. I know from time to time you may get that feeling as well. In mathematics, again, it is all about some basic rules that you must adhere to, you must follow. Remember, since we started factorization all the way through, we said that when given a problem to factorize, the first thing that you do is to look along that problem. Look along the problem or look along the expression and determine if a common factor exists. If a common factor exists, then we factor it out. If you can't recall how to factor out the common factor, you can check a previous video. But here, when we look along our expression here, we are seeing a common factor. What is that common factor? That common factor is 5. So we factor out that 5. 5 multiplied by what is 5a squared. When working problems in mathematics, from time to time, I myself may forget something. So the journal advises that you always check back. Some students seem to believe that checking back is a sign of not knowing what to do in mathematics, is a sign that you may not be as intelligent. That is not necessarily true. You should check back to ensure that you understand the steps, you understand the rules that govern the solution of a problem that you are working. So don't be afraid to check back. We have some videos, a series of videos. If at any point in time you have any problems with anything that we are doing, you can hit us up with a comment, or you can just check back on one of the previous videos that we had so far. So we're saying that we're factorizing here. So it's 5a squared minus 20b squared. Common factor is 5. 5 times what is 5a squared? 5 multiplied by a squared is 5a squared. And 5 times what is negative 20b squared? It's going to be negative 4b squared. Now, most students, should I not say most, I've seen students stop right here. This question is usually worth about 2 marks. And I've seen students stop right here. And if you stop right here, you're only getting 1 mark. So let's see where the other mark lies. If you look in the brackets here, if you look in these brackets, we are doing differences of 2 squares. If you look in the brackets, tell me what you see. It is a squared minus 4b squared. It's a difference, subtraction is taking place, and a squared is a squared, and we are subtracting from that 4b squared, which is going to be 4b squared is 2b all squared. It's a case of difference of 2 squares. Once we have a case of difference of 2 squares, the questions generally say factorize completely. Once you have a case of differences of 2 squares, what you have to do is you have to take the first term, it is a, add it to the second one, 2b, take the first term, a, subtract from the second one, 2b. And that's how you factorize difference of 2 squares. But we need to combine this, what we have here, to what we have here. So what we shall do is to attach to this 5, and then I'll use some square brackets here. Using some square brackets, it is going to be a squared minus 2b, using my square brackets, squared. So that's what I have. A squared is a squared, and 4b squared is 2b all squared. So it's a case of difference of 2 squares. So we write 5, and then a plus 2b, a plus 2b, a plus 2b, and a minus 2b. And we have completely factorized this expression. Nice. Initially, it looked as if it would have caused us some challenge. But once we follow the rules, once we follow the steps that are utilized in factorizing terms in algebra, we were able to figure it out. Let's look at another one. Factorize p cubed minus p. Is this a case of difference of 2 squares? Of course, it doesn't seem that way. This is p cubed, and this is p. Do you know of any term that you can square to give you p? Or of any term you can square to give you p cubed? I don't know of any, but I know that the first thing we said when factorizing, we are supposed to look across the expression and determine if a common factor exists. If a common factor exists, then we have to factor it out. So looking across this expression here, do we have a common factor? Of course, p is common. So factoring out p, it's going to be p multiplied by p times what is p cubed? P squared. And p times what is negative p? It's negative 1. Are we finished? Look in the brackets to see further factorization can be done. Within those brackets, we have p squared minus 1. Is this a case of difference of 2 squares? P squared is p all squared, and 1, as we said before, is going to be 1 squared. So this is a case of difference of 2 squares. To factorize a case of difference of 2 squares, take the first term, add it to the second term, then take the first term, minus it from the second term, and we have factorized the difference of 2 squares part of the question. So what we then do is that we join them back. Joining them back here, we have this. It is now going to become p brackets. Now remember what we said, that p squared minus 1 is a difference of 2 squares. I'm going to use my square brackets. So it's p squared minus 1 squared. Difference of 2 squares. So what we then do, once we recognize it's a case of difference of 2 squares, take the first one, add it to the second one, and then we take the first one, subtract from the second one, and we have completed our difference of two squares problem. That's how we factorize. Any problem in algebra, the first thing is to determine if a common factor exists, factor it out, then evaluate each of the expressions that you would have created to see if further methods of factorization or other methods of factorization can be used to factorize the problem.